Thanks, Mirko. Thanks to the IT for the invitation and for trusting the special session about hyperspectral data. I'm quite happy to have this keynotes invited because, as already briefly introduced Mirko, we are at a stage where, let's say, the user community is more or less aware of how much hyperspectral is going to be, one of the key technological instruments that will be useful for a lot of application. So, in order to introduce the second session, we have discussed with Mirko, but also with Gabriele, how much is important to set up what we call the starting point. Of course, it's more than 20 years that scientific community and also, industry is working on hyperspectral, but we are, as I would like to stress, at the very beginning. So we are at the right step to understand how much hyperspectral sensor data and information can really support a lot of downstream services. So in this case, we have discussed and invited, of course, the European Space Agency, setting up the scheme about CHIME, application domains and ongoing studies, and how much we all know that the Italian community, but not only the Italian community, is contributing to that. Then we have invited two national agencies that are dealing with let's say, real data. NMAP is going to deliver that, so we have invited Anke Schiefling to illustrate what the German spaceborne imaging spectroscopy mission is at the stage. And of course, we are completely happy about the possibility that Ettore Lopinto and Patrizia Sacco will share with us all the basic information about the Italian PRISMA mission, so product and next phase. Of course, this is going to be one of the key issues, because both for the CHIME and also for the let's say tandem synergistic activities that also PRISMA and NMAP can bring to the scientific, but not only scientific community, is really important. So I really would like to stress that our idea is this a new starting point after a long time. So I leave the floor to Jennifer Adams, that will illustrate the Copernicus Hyperspectral Imaging Mission, CHIME, application domain and ongoing studies. Jenny, the floor is yours.
Hello, thank you very much. So I think I will also be presenting my co-presenter, Marco Celesti. I think he's here as well, and he will be sharing the screen and starting the presentation. So yeah. Marco, if you were there.
Yes, we can see Marco. Yeah. Thanks.
Yeah. Okay.
Good afternoon, everyone. And in fact, I'm sharing this presentation with my colleague Jennifer Adams. I will start with an introduction on the CHIME mission, and she will present more about the scientific support activities that are being performed and will be performed, saying in support to the mission. So first, I thank the organizers and you all for inviting and for attending this conference. It's a pleasure being here, and honestly, thanks also for the nice introduction to Mirko and Andrea, because I think I can only share your view of a new starting point of something which was moving a lot in the last decades, but now really is coming to turning point, thanks to the concrete activities that are being performed and to the data which are being streamed now by PRISMA and will be by NMAP, SPG and CHIME. So thank you again, and I'll go quickly through my slides, starting by the fact that CHIME is part of a larger effort from the European Commission, ESA and EUMETSAT, of bringing 6 new high priority Sentinel expansions missions to space in order to basically fill the current observational gaps of the Sentinel constellation. And in particular, CHIME will provide hyperspectral imaging data, and together with the other expansion missions, the main aim is to really bring new insights into some of the key processes of the Earth system. And these 6 missions are foreseen to fly in the second half of this decade. CHIME in particular is scheduled for the 2028-2029 timeframe for the 2 satellites, CHIME A and CHIME B in orbit. Main aim of CHIME, as I briefly said, is to provide routine hyperspectral measurements global scale in support of EU and related policies, with a particular emphasis on policies and applications in the food security, agriculture, raw materials, and soil characterization, but without forgetting the fact that the flexibility and the degree of information content within the hyperspectral data are useful and will be useful for a number of, let's say, additional applications in biodiversity and forestry management, as well as for the hydrosphere, so for inland and coastal waters and snow and ice. Technically speaking, the key mission requirements for CHIME are to cover, let's say, the vast majority of land and coastal areas with a revisit time of 12.5 days, and the 2 satellites are in orbit. The spectral range covered by CHIME goes from 400 to 2500 nanometers with a bandwidth of less than 10 nanometers, and continuous coverage of the spectrum. This enables the detection of a way larger number of spectral features compared to multispectral observations. But at the same time, CHIME is providing these at a relatively high spatial resolution of 30 meters, with a high radiometric accuracy and a low spectral and spatial misregistration, at the same time maintaining a high signal-to-noise ratio in order to at least match the performance of other international missions that were mentioned before, such as PRISMA and MAP or the NASA SBG. At the moment, the full consortium for the space segment development has been established, and the mission is currently in the B2 phase. So basically, there are main contractors involved in the large enterprise domain, which is listed here, plus relatively consistent share of the project is covered by small and medium enterprises. At the same time, all the scientific support activities that will bring the satellite and the mission to the launch and the commissioning phase are being implemented as of today. This is just a render of the conceptual design for the telescope and the 3 spectrometers that compose the main instrument on board CHIME. And in terms of core data products provided by the missions, these 3 are listed here. So the level 1B of atmosphere radiance in sensor geometry, level 1C orthorectified of atmosphere reflectance, and probably most relevant for most of the communities, the level 2A orthorectified surface reflectance products. These 3 will be distributed operationally and from the baseline of the data distribution from CHIME. At the same time, a larger number of higher level products has been evaluated together with the mission advisory group. And here I report, let's say, a selection of these covering the vegetation, the topsoil, and the raw material domains. At the moment, 5 of these high priority products have been shortlisted by the MAC, and it's within the project the development of operational products is being performed basically, and this will take place in the coming years, and in order to support, let's say, the evaluation of the feasibility and the development of these products, a large number of scientific support activities has been performed during the phase AB1 of the mission, and new contracts are starting right now in order to further develop these. And with this, I leave the floor, short introduction, I leave the floor to Jennifer Adams for covering this scientific support activities.
Great, thank you so much, Marco, for the introduction. So yes, as Marco mentioned, I will go into a bit more depth on the scientific support activities that have been conducted throughout the CHIME phase A and B1 phases. So this is during the development of the CHIME concept. So we have a number of support activities that were kicked off in 2018. The first of which was the requirements consolidation study. So Marco, if you can move to the next slide. So the requirements consolidation study was kicked off in 2018. And the main aims were to consolidate both the user requirements and also the main mission performance requirements, such as the radiometric accuracy, the spectral resolution and range, the spatial sampling distance. And here is a really nice example of some of the developments that were done during the requirements consolidation study on algorithm development for the high priority prototype products that Marco has just introduced on the last slide. So during this study, they looked particularly at developing new retrieval-based methods based on artificial intelligence on some of these priority products. So here we can see some nice examples of within the vegetation domain and also the soils domain. So this is covering agriculture, which is one of the main pillars of our thematic application areas within CHIME. And these results were developed based on a campaign that was run by ESA in 2018, where the NASA AVARIS instrument was flown over from US to Europe and covered 6 sites covering these main application areas. So here you can see an example of chlorophyll and nitrogen retrievals over this Grosseto site, which is an Italian site. And in addition, some examples of clay, silt, sand, and organic carbon for the soils application domain, using both the AVARIS instrument, but also the APEX imaging spectrometer, which is a Swiss-based imaging spectrometer. So this study was kicked off in 2018, was actually continued right up until this year. And the study have been looking specifically at algorithm development and preparing the user community for hyperspectral data and starting the initial development of these ATBDs for CHIME. Marco, if you go to the next slide. I then want to talk about one of the other support activities that we've been running since 2018 as well. So this is the CHIME end-to-end simulator study. And the main aim of this study was to simulate the end-to-end mission performance from an observed scene to these level 2B high priority prototype products that we'd introduced before. And so the main use of the end-to-end simulator was supporting the performance consolidation, particularly at mission level, being able to trade off the impacts of these different mission performances on the mission products. So these are the core data products that we're looking at and also the priority products. And we're also looking at an early preparation of the user community for being able to exploit CHIME data. So this end-to-end simulator has some different modules. So it uses a model of the instrument from CHIME. It has an OPSI module, which basically simulates what the CHIME data would look like at level 1C. And then it's able to propagate the algorithm development through to these high priority prototype products and then perform an assessment performance on these products at both the level 1 and level 2 of the mission. And on the right-hand side here, you can see a very nice example of canopy nitrogen content using the end-to-end simulator over a site in North Munich, actually using Prisma data, which will be introduced in the next talk by Ettore Pinto. And this is actually one of the first times that we've been able to produce such a kind of data product of canopy nitrogen content, because it typically requires hyperspectral data. And so being able to use Prisma data within this end-to-end simulator, we are able to show that hyperspectral data can really provide a delta, shall we say, over typical optical missions that have been in orbit up until now. And if we go to the next slide, I'd also like to show a couple more examples of minerals and soils as well. So here you can see a couple of nice examples. Firstly, for kaolinite, which is an important mineral and one of our priority products. This is over a site called Agenis in South Africa. So it's northwest of the Northern Cape. And what we can see here is that on the bottom, you see the accuracy classification levels are really high, not just for pure kaolinite, which is in the top row, but also when there's actually mixed pixels. So it's able to detect kaolinite even when there's dry vegetation and other minerals as well. And this is one of the algorithms that have been developed in the end-to-end simulator study. Another algorithm that's been developed is for soil organic carbon, and this is over a site in Germany called Demmin. So this is actually one of the priority sites for CHIME. And what we can see here is that we actually have some very nice results for soil organic carbon. So you can see on the very right-hand side here, the reference at the bottom versus the estimated using the end-to-end simulator. And we see that we actually are able to quite well extract soil organic carbon using these preliminary algorithms that have been developed within the end-to-end simulator. And if you go to the next slide, Marco, I'd like to talk about one of our main support activities, which is called the HyperSense campaign. So this was a campaign that was originally supposed to run in 2020, but due to COVID was postponed until 2021, sorry. And this is a campaign, a joint campaign with NASA and ESA, and it's led by the University of Zurich. And the main aim of this campaign is to fly the AVARIS next generation imaging spectrometer over multiple sites in Europe to demonstrate key algorithms over the key application areas of CHIME, and also the Surface Biology Geology mission, which is a similar mission to CHIME being currently developed by NASA. So during this campaign, we were able to collect a diverse set of data sets over a wide variety of European test sites. And we are able to then start to be able to test and evaluate new state-of-the-art scientific algorithms, such as those developed within the support studies that I've presented here. And they will also be provided as inputs into future support activities, not just within ESA, but within the entire European hyperspectral community. There's a couple of websites at the bottom here. One is the ARIS Observatory website, which is actually monitored by the University of Zurich. And there you can find all of the information about the test sites, the kind of data that was collected, and in the future, all of the data that was collected within the campaign should be available within this site, so the community can go ahead and download the data and start developing algorithms themselves. There's also the Twitter account, which is a very nice snapshot of how the mission was conducted and has lots of images throughout the mission. So if you go to the next slide, Marco, there's just a couple of examples of the AVARIS acquisitions. So on the left-hand side here, we can see a site called Erdbach, which is in Germany, and it's an agricultural site that's quite heavily featured in our CHIME priority sites. And we also have the Venice Lagoon, which maybe quite a lot of people on the call know here very well. And it's one of the main CalVal sites for hyperspectral missions, particularly for aquatic water and coastal areas. And then if we go to the next slide, and here is a couple of nice images as well. So not just did we have acquisitions from the AVARIS spectrometer, but we also had in situ measurements on the field, which were able to calibrate the AVARIS next generation spectrometer. So here's an example of some measurements that were performed at the Venice Lagoon as well, and also the Rio Tinto site in Spain. So this is a site that's for minerals. And so here you can see an artificial target that was used to calibrate the AVARIS instrument. And if we go to the next slide, so here is just a very brief overview of the site acquisition status. So we can see that many of our sites, I think around 20 sites, were able to be acquired from the 30th of May up until the very end of July. And so not just did we have AVARIS sites, but we also had support from the ASI PRISMA mission and also the DLR DESIS mission throughout the campaign. And so here we can see in the blue when we were able to have overpass of the PRISMA mission at the same time in which we had the AVARIS acquisitions. And if we go to the next slide, Marco. Here we can see an example of some of the one of the PRISMA acquisitions, which is over the Iolanda de Savoia site in Italy, which is in the north of Italy. And so, as I mentioned, not only was it important to be able to get airborne spectrometer acquisitions, but also to have concurrent spaceborne acquisitions from the PRISMA and the DESIS missions. And I know that Ettore will go into a bit more detail about this, but just to say that it was a very, very successful and quite difficult to manage activity, but in the end, we managed to get 86 sites, 86 PRISMA acquisitions over the same sites that we acquired during the HyperSense campaign, which is a real success story. And if we go to the next slide, Marco, we also had DESI's acquisitions throughout the campaign. So this is an imaging spectrometer on board the International Space Station in preparation for the MMAP mission, which will be presented coming up as well. And here we can just see a few examples of the LBAC site that I had mentioned before. And we're actually able to get multiple acquisitions throughout the campaign. So here we see some examples from April, June, early June and mid-June over this site. And if we move to the next slide. And finally, here's just a very nice example from the requirements consolidation study. So this is courtesy of Claudia Giardino on the use of PRISMA and DESI's spaceborne imagery to support CHIME. So inland and coastal waters are one of the important secondary applications for CHIME. And within the study, some CHIME-like products have been generated using PRISMA and DESI's data over a couple of Italian lakes, so the Mantua lakes, which was focusing on phytoplankton and biomass of aquatic vegetation, and also over Lake Garda, the retrievals of water quality and bottom types using PRISMA images. And it's just a nice example to show how the PRISMA and DESI spaceborne imagery can be used in preparation for generating CHIME-like products. And I think the next slide I pass back over to Marco to close the presentation.
Thank you very much, Jenny. Yes, this is just to build on what was presented and to thanking again the ASI and DLR and NASA for the really great collaboration that was put in place with ESA in order to really not just, let's say, perform these activities, but also set the basis for an even stronger community around hyperspectral data. And what we can say on our side is that we are working on trying to let's say provide consistent data and at some point also say interchangeable data sets between the different agencies and the different mission towards, say, a better exploitation of this data from the users. And I also take the chance to thank all the different groups and institutions that were working together in order to support these activities. And with this, I really thank you for your attention, and we're open to questions, of course.
Thanks, Marco and Jennifer. Thanks also to be almost in time. No problem for a few minutes. You know, we have a lot of things to talk about, so it would be good then to have, you know, a further section of discussion there. So I leave to Anke. So for introducing the NMAP, the German Spaceborne Imaging Spectroscopy Mission. So please, Anke.
Andrea,
yep.
Mirko, I take again I remind to the audience that please, if you have any doubts, curiosity, or specific question, please use the chat.